Hi, I'm William Yu, and my partner is Hyunbin Park, and together we are MoViSense, fingerprinting motion across visual and mobile sensor data. The primary goal for our project is to identify and match motion across visual and sensor data. Our key intuition is that visual data and mobile data are very different, but there is a way to extract a common set of motion information across both media. Why are we interested? This experiment can expand to form the basis for an alternative communication to MAC addressing. Currently, devices on a shared network need to know each other's hardware identifier to talk with each other. However, this may not make sense in a public environment where not everyone knows each other's hardware identifier. For example, if I were shopping at Walmart, Walmart may want to send me a targeted advertising based on the motions I've made while in the store. They could broadcast a message containing a coupon for, quote unquote, a person who just walked to aisle 4 and is now looking at fresh bananas. My phone would recognize that I'm the one who walked to aisle 4, and it would relay the store's message to me accordingly. On the other hand, beacons are not a viable alternative to this technology because they travel really far and reach multiple users. There are no granular and individualized advertising opportunities. The project challenges were divided into three broad categories. Number one, extracting motion data from the mobile sensors, including the accelerometer and the gyroscope. Number two, extracting motion data from the video. Number three, finally matching the two together. We used several sample reference recordings that we made using our Android devices for sensor data and a MacBook Air front-facing camera for the video footage. Now, from the mobile sensors, we acquired data using our smartphone's accelerometer and gyroscope data. We then smoothed out the data using a low-pass filter. We divided each person's data into 1-second intervals and ran the data through an algorithm to decide what direction the user was facing for each interval and whether the user made significant motion or not. Next, onto the video. After capturing quality video using our camera, we took the difference between the first frame and every subsequent frame to determine significant motion. In the case of multiple subjects on the screen, we find the most likely object using overlap ratio with all boxes from the last frame. And finally, to overcome subject obstruction, we use Kalman filtering, which is shown by the blue box. And eventually, we take the motion data from both media and we start matching them against each other, time shifting as necessary because the phone and the video may not have started data collection at the same time. We find the iteration that yields the least amount of differences across both motion data for both people on screen, and we return the set that matches best as our highest confidence answer. In conclusion, we successfully matched up phone and camera data with about an 85% absolute accuracy under ideal conditions. With multiple users on screen, we can always match the two phone data to the two objects in the video data given a 15 to 30 second video clip. Now you can see the full results of our video processing algorithm. The blue box is the Kalman filter and the green box is the regular motion tracker.